Hello everybody, welcome to the SNES Tracker channel. Tonight I'm going to be trying to figure out how to use the Blargg's APU API. When I say APU, I'm referring to the audio processing unit of the Super Nintendo, and the API, Application Programming Interface. So, where we left off last, I had created a sort of improvement on the code that transferred data from the SNES side over to the APU itself. That data was a sample and a program to play that sample. And that program was written in SPC 700 assembly language. So this is really tough stuff for me. So I'm doing the best I can with it, and I'm just going to try to get started right now. So the first thing I'm going to do is pull up a new window here and try to figure out where I'm trying to take this train tonight. So let's go to SNES Tracker. PC Tracker. Alright, hey. Oh, gotta switch my branch. So let's open this GitHub up. I'm currently in my GitHub Pages branch, which allows me to have like a static web page, or you could even almost call it a website associated with my GitHub repository. By the way, this is hosted on github.com/Bazzanotti. That's right, spelled right up here, Bazzanotti right there. So basically, the files are kind of weird when you switch branches. There's references to like the entire repository's files, but not really. For instance, in the GH Pages branch, I'm really only having an index.html in here, but you can see all these other files. So, but what's is weird is that not all the files will actually display. I don't know what that's all about, but I know that I have to get back to my master branch, which I do by clicking this check mark. So that worked right there, and I use this PC Tracker to keep track of the PC side of stuff. Let's see, what's this? I should really call this play sample, but I should git move that so that git keeps tracks of that change. Let me see if I can do that. I think I can just do this. So I want to call it play sample. Forget that underscore though. Alright, that's nice. So that's tracked. It's good to remember that. So I'm gonna open this up in my favorite editor, Sublime. So I just want to narrow down the essential files that I'm gonna need here. There is the spc.asm, which is my SPC program, which expects to be uploaded at the address 1000. So I'm just gonna make some summary notes here. SPC program. And this is the code needed to play the sample. It just initializes some things like the main volume on the speakers, default pitch of the same pitch as the sample's recorded pitch. I like to call that the bass pitch or the C4 pitch. And then some other stuff that I honestly haven't brushed up on yet, so you know, it's been a while for me. Source number 0, yeah, so, but I'm not too worried about that right now. I can learn that later. But why don't we learn it right now? You know, because why not? I'm learning to be patient, so I don't mind going in and learning this stuff. So to learn this stuff, I go to Super Nest Sound, and there's the register used. So we can see this is register 4 is the source, designates the source number, but that doesn't tell me too much. There's like a whole thing about this source stuff. Trying to learn about these sources. Sorry, I hope I'm not going too fast for you. I'm just trying to find where the pertinent information's at. Where's like the source address thing? Here we go. Right. Addresses designated by D7 equals 1 of 80s SR1. So that has to do with some sort of gain thing. I guess gain operates independent of a sample being played. I'm trying to figure out the purpose of this ADSR. I think it's address, right? I think it's the address of these source entries, and I'm trying to learn more about these source entries. So if we look at this source, no, if we look at this, what's this 5D? 5D, offset address of source. Oh, so this is really what I wanted. This is what I thought I was looking at with this ADSR, but no, that's not. That's attack decay, sustain, release. That's the envelope. I'm sorry, guys. You smarty pants dudes out there are probably like, yo, Baz, it's not what you think it is, dude. It's an envelope. So where was I at? The DIR, offset address of source directory. So I want to learn more about the source directory. Here's my source directory entry. So first of all, that offset is like 30 equals 3000. Where can I learn more about that? Oh, here we go. Oh, so this is a source data entry right here. It's 4 bytes. This is the start of the sample, which gets uploaded at 200, and we can confirm that by seeing this. You know, we loaded at 200 the Blargg.brr bitrate reduced sample. And then, what's this? 91.2. I wonder what that is. It's a loop. It's some sort of loop. Source loop start address. The 16 address is the leadoff address of the loop start block. Leadoff address of the loop start block. I don't know enough about the loop stuff. Oh, so this... I don't know if this is on the loop. See, I'm starting to get a little curious whether I can try to loop that sample, but that's going out of the context of what I wanted to do tonight. But basically what we learned is... we learned what the source number is. But I'm still trying to put it together. So let's go back to the manual. So yeah, there's a directory that specifies, you can almost think of them as instruments when you're tracking, you know, they have samples, except in this case, you can only have one sample going on. And so you specify what instrument, so to speak, that you want to use. And in our case, we specified instrument 0. Alright, cool. Learned something new. Getting them readjusted to SPC once again. The gain I still need to learn about, but anyways, definitely trying to go back to my summary notes. So the sample, oh, yeah, I'll save these notes somewhere, just put them on the desktop for now. Okay, I'm recording, right? Yeah, okay. So now what I want to do is start learning about this, and I'm not really sure where to start. I want to learn about Blargg's APU. Like let's start with the README. Let's just read this together, everybody. So this is Blargg's SP700 APU emulator. This library includes a full SPC emulator and an SDSP emulator that can be used on its own. The SDSP is like the digital signal processor. I think the S stands for sound, but I don't really know. 2 SDS, a highly accurate one for use in a SNES emulator, and a 3 times faster one for use in an SPC music player or resource limited SNES emulator. I'm not sure which one I want to use yet. Can be used from C and C++, full with cycle accuracy in most cases. Load plays and saves SPC music files. So that's good to know. Can save and load exact full emulator state, DSP voice muting, surround sound disable, and song tempo adjustment. The accurate is based on past years for others and hundreds of hours of research by me. Passes over 100 of strenuous timing and behavior validations that were also run on the SNES. The first with cycle accuracy, providing emulating every DSP its exact CPC. Shay Green, shouts to Shay Green for writing this thing. I love you, man. Oh, you see that he has a Google group. Could be useful to go there. It's probably old. Build a program consisting of demo. Yeah, did that already. If you don't know, I have a make file of this stuff because these directories don't come with make files in them, like his Game Music EMU or his SNES SPC. But I have that all on the GitHub, so you can do that if you want. So I want to figure out, like, this is probably going to be a good file, and also like figure out the purpose of all these source files. Records SPC file to wave sound file. From silence. Save loads exact emulator state to from file. Communicates with SPC how SNES would. I mean, this is an interesting one. I'm gonna start flagging these with stars. the heck? I think I'll give you guys a break. I'm being pretty quiet right now. Proper file opened, spc.h in the SNES SPC subdirectory, and I'm looking for things that interest me as far as how can I sort of preload the SPC RAM, like a quick way to just kind of pre-initialize the RAM, you know, and start the APU up or something like that. And one of the interesting things I found is this savestate save load, which is only available with the accurate DSP version. And that might be really useful because it's a way to just preload the entire RAM space with some sort of image. So definitely interested in that. Oh, let me get back to my spot. Something that Blargg mentioned in the SNES SPC was that the C++ interface is bound to change, but you know, who knows how old this README is? Is there a date? I don't know. I feel like it's old, meaning that the C++ interface probably isn't changing anymore. But he made a recommendation worth noting, and it was to compile with the C interface if you're going to link with a shared library, or to link statically if you're going to go with C++, which I just want to remember that. Goes on to say there's three main rules for this library: full SPC emulation in a SNES emulator, DSP emulation in a SNES emulator where you are emulating the actual sound CPU, or SPC playback and SPC music file player. This is probably the closest thing that we are. Excuse me. So I'm gonna go on and read this. Important. The APU engine, you know, Blagg's APU thing, emulator, doesn't come with the IPL ROM, which may or may not be necessary, hasn't been determined yet. For spc.txt, there's a section detailing SPC music playback, where we can create an SPC emulator with the SPC new, check for null. Load SPC with SPC load SPC, check for error. Optionally clear the echo buffer with SPC clear echo. Many SPCs have garbage in the echo buffer which cause noise at the beginning. Okay. Generate samples as needed with SPC play. That I'm not too sure about. When done, use SPC delete to free memory. Check out game music ammo. Detailed in SNES underscore SPC.txt. So that's good, it's right here. But what I'm now starting to really wonder is, for things like the program status word, I'm wondering what the default value would be at boot up, so that I could make an SPC save state with the defaults, except for the actual area of RAM. That's what I'm wondering how to do. And then next up is the library compilation. There's some good notes about this. There's some good notes about how the library is written to link in a C program without needing the standard C++ library, and how it doesn't use exception handling or runtime type information, so you can disable these in your C++ compiler to increase efficiency. This is good to know right here. I don't know if I'm going to use C or C++ yet. Probably C++. I don't know. Alright, putting it on pause. The library does not throw any... Let's read the whole thing. To improve usability for C programmers, C++ programmers unfamiliar with exceptions, and compatibility with older C++ compilers, the library does not throw any C++ exceptions and uses malloc instead of the standard operator new. This means that you must check for null when creating a library object with the new operator. Very important. I'm going to put it in the notes. I want to confirm with everybody is that here's a sample funk-bass.wave. Here's how the sample sounds. And if I play a C4 on the keyboard, so we can see that C4 is the pitch that's considered the sample pre-recorded pitch. Just wanted to clear that up. And there's really handy notes on my blog called Productive IRC Sesh that talk about the reasons why using C5 as a base for the SNES tracker could be more useful, and it details why in there. Okay. Trying to catch up where I'm at. There's the accurate SDSP emulator and then the fast one. And the accurate one looks like the one to use because it has less limitations in its emulation. The only one that's a concern is this one right here, where the muting, very rapid toggling of the mute is not emulated properly, and it doesn't really say what should happen and what actually happens. I wish that Blargg would have written that. So that's up for discernment. No other known inaccuracies, so that's great. And I already read this fast SDSP limitations, and I don't know, I just stray away from that stuff. It may be possible to use both of them, or to optionally pick one or the other, but I'm definitely just going to go with the accurate one. And then there's limitations in the CPU, the SPC 700 CPU, which I'm not really sure what, like how some of these limitations correlate. Like opcode fetches and indirect pointers are always read directly from memory, and the DSP is not caught up for these fetches. So I don't know what, like, okay, the DSP is not caught up for these fetches. Well, like, what is that? What's the point? Like, the bad things happen because of that? So I don't get that. Attempts to perversely execute data in registers or an area being modified by echo will not be emulated properly. So that doesn't sound too bad. It has not been thoroughly tested. Test register not implemented. Echo buffer can overwrite IPL and does not correctly update. So yeah, I mean, this is just like minor stuff. Like this one right here and this one is stuff that would happen. Like, that's a little bit of a concern. The echo buffer can overwrite IPL wrong, but nothing that I can really be concerned about right now. I'm just getting started. Now that I've read up on that, rather than check out something like savestate.c to learn about these save states, I'm going to check out the game music emu. I don't know what I'm going to do yet, So I'm going to put you back on pause, and I'm going to try the key combination this time. I'm reading gme.txt from the game music emu, and you might want to pause the video and read this with me. Yeah, right there. Alright, so I'm continuing studying the game music emulator, game music emu, and I'm studying the main player.cpp file. And in the init function, we init SDL, okay, video and audio. Make sure to quit at exit, and then this function I'm not too sure about, so I'm going to look it up. This is SDL 1.2 BTW, by the way. It doesn't say the metric of these values. Are they in milliseconds, for instance? Let's see if I can find something else. Oh, expressed in milliseconds. Did I miss that? Did it say that on here? Oh, right here. I'm blind. Okay. I'm not too interested in checking out the scope stuff just yet. Right here is what I'm interested in. Player equals new music player. Okay, so this will either load the first command line parameter or the file test.sbc. Player load file. Start track 1, path. Let's go to music player. Yeah, let's look at the load file function. Let's check this out. Create emulator and load game music file data into it. Sets out to new emulator. Let's try to look at the constructor for this guy. Well, the sample rate. You could set a music player init. But where does that get called? Well, by the time load file gets called, sample rate is set. So, default 44, but when does init get called? Probably hear sound init. Oh, player init. I missed it. Where was that again? Right here. Okay, let's go back to GME open file path. So what is that macro return error? I don't know what that's all about. Why the loop? I don't get that. So this seems to load a playlist too, which we probably don't want. I'll put this out. Okay, let's go back to player. Where am I looking at? We have to look at the low file and music player. Yep, back to player. Then we start track, one path. Let's check out the player start track. Let's check out emu. What kind of data is that? Music emu. Here we go. I think it was start track, right? Music emu start track. Why would he call the music emu? This is what I'm interested in. File data, file size. So let's look at how this file data got loaded. Alright, I gotta go back to player. I'm kinda lost here. I've lost where's the load file. Oh. Should be multiplayer, right? Wait a second. Music player must inherit from another class or something. Yes. Inherit some GME file, which has that. load file stuff. So let's check that out. The reason why I'm really interested in learning this stuff is because there's a way to also load custom data source using a data reader. It's very interesting, especially when the tracker will be modifying data on the fly. But for now, let's just look at this load file. Calls preload. Just check out preload. They all call preload. Oh, virtual function. Preload. Right here, helpful. Set temporary must be called, and then you'd call the GUI file preload. This calls unload. So let's see what unload is. Let's see if we can look at it in the header. Called before loading file and if loading fails. Didn't tell me much though. Clear the playlist, reset track count, clear file data. Okay. What else was I interested in? And we in.open. So what's in? Very unhelpful search statement. Oh, I'm so blind. GME file reader. Where's that defined? Hold up, got an IRC thing going on. Okay, GME file reader. So it's all based on whether you have zlib or not. And if this definition is not defined. Let's see if this thing. I'm kind of interested in this. Just your typical if open. Notice he's not using a file pointer, he's using a void pointer. Alright, look at all these source files open. Where were we? We were opening up a file. Where were we? Let's go back to the player. Yeah, we were here. We were loading the file. Post load, load. Where's this load? Oops. Right here. How come I didn't see that here? I don't see a load here though. Well, it must be, you know, just in the implementation. I guess, I don't know. I don't know how that works. Be right back. Let's check that out. It's up here. Load mem or load must be overridden. Okay. That must mean looks like some very interesting information in this gmu.txt. I really gotta check that out. Like now. I'm wondering what it's gonna be like when, but I'm thinking too far ahead. Just want to get back to the top level. Let's play along here. Super Mario World's 1-1 title 120. Update window title with tracking 30 seconds, player tracking right. I don't know what the Division of 1,000 is all about. Game track. Let's see. Look. Cool. Alright, that was the start track right there. So the path used in start track in this case was only to it was only to get the file name in case the SPC file didn't have a game title in its file contents. We initialize some basic variables here. Let's talk about this SDL delay, huh? That was in milliseconds, right? So every 10 milliseconds, which is like it says this is the delay granularity anyways, usually. Update scope, which I'm not worried about right now. Automatically go to next track. Handle some key events. Cool. How is the audio getting outputted? Is that with SDL? Like, player start track. Let's check that out a little more. Here we go, SDL pause audio. I want to learn more about this audio. So like, check this sound init here is where we open the audio up. So the music player is responsible for the STL audio portion of it all. Sound output driver. Yep. But how does it get called? Like a sound audio. Very fortunate to have this audio driver already written. I don't really understand how this SDL audio is actually getting played, but I may be able to just bypass that understanding. Has to do with this buffer getting filled. But I'm not going to learn about that stuff right now. What did I do? Did I change the file somehow? Definitely don't want to save that. Okay, so need a break. Well, ready? I guess for the first time, I'm just going to manually convert my SPC program into an SPC file format, which is detailed somewhere. I kind of already forgot. Oh, brother. I think it was... probably in SNES SBC, if anything. Right here. Okay. So, SBC. Okay. I'm gonna see if I can just write a little batch script to do this. So I'm gonna go on my SNES side. There are two important files. These two important files are detailed in the summary. The SBC and the sample. So, let's see if I can use my hacking skills to do this. Okay, so Perl E. It's been a while. Let's see if I can remember to do this. Print. Try that. Let's put it into a temp file. Derp. Okay, let's open it up in a hex editor. Just make sure. Basically, I'm just trying to fill up an SPC RAM image. Alright, so that's working. So I'm filling up the first 200 with random crap. I should really make this a little script, so let's touch a file. We'll call it, create SPC. Make it executable and Sublime. And also, I'm going to copy this. Then I want a cat SNES side slash Blargg.brr. So this is an old sample I made from a WAV file back in the day. More like a year ago or so. Alright, so that goes in at 200. And then I need to look at the file size. What's going on here? It's not, oh, slash Blargg. This is 1080. I'm like so out of it. Whatever, maybe I'm stupid, but it doesn't matter. Just keep going. So basically I want to do 1080 in hex plus 200. So that's 638. So 1000 minus 638. 9C8. I wish I had a program that would do these calculations for me, but for now I'll do them manually. So just for now. Is that really? Yeah, I guess so. Okay, and then what was it? SPC.on. Yep. And that's for the most part will be it. else can be 0 for all we care. But I think we should probably... I'm a little worried about the program status word. I'm not sure of what the correct default would be for that to be desired. The PC needs to be set at 1000. Alright, so let's fill the rest up. Alright, let's run the program. So this is 1063 bytes in hex. Let's confirm. Good. So it's 1063. So we need to do 10,000 minus 1063. EF9D. So EF9D. I don't know why I'm doing it this way. Probably easier to write a C program, don't you think? And I could actually query the file sizes and make it all programmatic. But I'm letting it get the best of me, still going manually here. Let's run this script and check out that file size. 65536. I should know how that exact number is correct, but I just can't. Okay. Wonderful. Now we can start plugging in those register values and stuff and such. So these can be, I honestly don't know. I should probably check them out. I'm so reluctant, but let's do this. So yeah, let's put them at reset values. Basically all zeros here. Indeterminate are all zeros. Whoops. So for another 10 I'm going to do zeros. And then F4 to F8. That can't be right. Because we just did F0 to FF. That's weird. What's that all about, dude? Well, we'll just leave those at 0 as well. So for another 4. And then the PC. Is this little endian? Crap. I need to see what this looks like. So here's how I'll do that. This is a cool trick for you to learn if you don't know it. If you want to see what it looks like in hex, you do it and you OD. Well, there's the problem is that I repeated it several times. 0, 0, 0. Yeah, so it's little endian. So I think I have to put it like this. Exactly. Okay. So that will be the program status. Probably very crucial, right, to set that. That's why I set it. And then the AXY and the we have to check out the PSW. These can be 0, 0, 0. AXY, so that's times 3. Let's check out the PSW. I'm just going to set this to 0. Well, the SP. I'll set it to FF. What else do we got here? Internal DSP registers. I'm just gonna set all this to 0, so the next 5 will be 0. The next 80 will all be 0. I'm just gonna leave that blank, I guess. It's internal anyway. Let me run it, make sure it actually worked. So let's put us up at 10, 180. Is that what I'm supposed to be? 180. We should be at 100A0. I must have messed something up. Let's go to right here. Got my PC. AXY. Looking status word. SP. And then at 1020. Oh, so this is right. So this should be. That's perfect. Great. Alright, so at this point I'm going to move wrong file type for this emulator. So there's no something wrong. There must be something wrong with my SPC file, huh? A more detailed error message would really help me at this point. But I wonder what I'm missing. It's time to Google SPC file format. I don't know, I feel like Wikipedia is going to let me down, but let's check it out. Wait a second, I saw something cool. Can't be bothered with that right now. This SPC file format's so much different from what the other one was telling me. SPC save state format. Yeah, isn't that it? So if you want to learn more about state copying, but yeah, this is the real deal here for the file. I'm not really interested in the SPC file as much as I am a state. But I should really learn both. So let's start with the file, huh? So the first thing that needs to get outputted is this string. I'm just gonna have to write a C program for this. BRB. Pseudo code it out. So we're going to want to process a couple things here. One is going to be what? We want a sample file name, and we want the SPC object file name. So those need to get specified. Let's see, we'll call this -s. We'll call this -o, no, -p. How about -p for program? Alright, so we want to load up the files. And really this will probably get the file sizes. Load up the files. Start crafting an SPC file using SPC file format. And I don't even know if version 0.30 is like the latest or not, so no idea. Start crafting SPC file format using format.txt. So maybe we could do like a craft skeleton call where the craft skeleton, don't worry about typos, add 0, right. I don't know if that's a decimal 26. Must be. And then header contains ID 666 information. We'll do the first example without first. Right, no ID 666 info, which is 0x. Oh, it's 26. Must be decimal. So I'm hoping to just iterate in an address pointer, increment it as we write, so I don't have to keep track of where I'm at. Do some sanity checks. Should be at 5. Right, SPC 700 regs. PC A, X, Y, PSW, SP, lower byte, 2 bytes reserved. Should be at 0x2e. And if there's no ID 666 tag here, does it still get filled with blanks or what? I don't know. Skip this ID data. Go to 0x100. SPC 64 kilobit RAM upload. Meaning that's 0x200 plus. Upload sample at 0x100 plus 1000. DSP registers are at 10100. Write all zeros. That's 80 times. Huh. 64. So we'll just say memory use an APU to read only. I'm just gonna say write 128. We'll put this in play sample. We'll just call it export SPC. Let's see. Alright, now I'm gonna go try to fill in the holes that I made for extracting arguments. I'm filling in the blanks right now as we speak. I'm hating how this looks. I think we want 3, right? Let's just give this a shot, huh? Let's see what happens. What have I done? This code is so foreign to me. I'm just kind of like, what's going on? You know what I'm gonna try to do is let's give this a shot. Yeah. Just basic debugging. SERP gets called, but you know, perp doesn't. Dang. Oh, it didn't even compile. I'm gonna go to that get ops. I don't like the way I wrote this thing. You can tell what's going on. Implementation of the arguments. If you must know, I got it from this cs.rutgers.edu blah de blah website. So with that information, I really need to go get some water. Leave you guys with this right here. So.
So I'm back. Where was I? You really got me. You really got me. You really got me. Oh, oh, oh.
I jumped way ahead, and I programmed the whole program here. It's almost 100% adaptive, with the only exception that I have hard-coded the sample address and the program address, but I do adaptively specify the PC, which is the program address. Oh my god, I should use the PC for that then. Hold on. PC plus 100 here. Perfect. And for the sample start address, this should really be specified as an argument, but I'm running out of arguments. I'm just gonna call it A for now. I mean, you got nothing to lose. I actually should really use this one. Alright, we need to add an A flag. That should be an array. Sample name, sample upload address. How's that for arguments, huh? Lol. See how that works. So I'm going to compile. And then I'm going to run the thing. So let's go through it. I specify my sample, which is SNESSide-blog.brr. I'm going to specify a sample offset of 0x200. I'm using the stir to ul function, which will automatically turn this hex and parse it properly as a string. I specify a program, which is my SPC object, binary SPC program, and then I specify an output file derp.o, but I'm really going to call this derp.spc, and then I specify a PC value of 0x1000, which is where the SPC program, spc.object, will be uploaded to, and also where the PC will be set as part of the restored registers, SPC registers. Alright, ready? Here we go. I'm going to run it. Okay, it ran. Now I'm going to go into my PC side and run the player, specifying derp.spc, and it plays. That is my program. To go back, I'm so happy that works. I'm just playing it over and over. So you can go back and we can watch how that play in a real Super Nintendo emulator. If we go back to the SNES side, I've got it in a file called music.smc. So this is going to run in SNES 9X. Yeah, it runs a little weird when it first plays, but I'll reset it. Okay, cool. And just for giggles, let's open this up on another emulator. Let's try BSNES. Sweet. And yeah, I had it just load up a white screen. Nothing crazy. Alright, so very happy about that. Oh, that's an old. That's old. So I've learned how to take an SPC, binary compiled, assembled program, a BRR sample, load them properly into an SPC file, and then load that SPC file into the APU emulator. That's what I've learned so far. Alright, I'm calling it a break at that point. Calling it quits. Peace out, everybody. I love you. Like, I love you a lot. Alright.